Let's say we throw a pumpkin off of a building. The height of the pumpkin is going to be a function of time. So maybe it's given by this function f of t equals 100 plus 20t minus 5t squared meters, where t is measured in seconds. Just so you know a little bit about where this function came from, it's a quadratic polynomial because we know that objects fall in parabolic arcs, and the 100, that's the height of the building. So that's where the pumpkin starts at time 0. The 20 is referring to an initial velocity with which we throw the pumpkin. And this minus 5t squared, that's the effect of gravity. What we're going to do in this video is calculate the average velocity of the pumpkin between times t equals 0 and t equals 1. And then we're going to calculate the instantaneous velocity of the pumpkin at t equals 1. And we're going to do this and just see how those things differ. So let's start with the average velocity. We know that average velocity is the change in height, so f of 1 minus f of 0, divided by the change in time, 1 minus 0. And we can just calculate these things. F of 1 is 115. F of 0 is 100, and that's in meters. And on the bottom, we have a time of 1 second. So we've got 15 meters per second for our average velocity. Wonderful. Now, instantaneous velocity is asking for a derivative. So we want f prime of 1, and we'll use our limit definition. So f prime of 1 is defined to be the limit as b approaches 1 of f of b minus f of 1 divided by b minus 1. So let's see what we can do to simplify this expression that we're taking the limit of. So f of b minus f of 1 divided by b minus 1, when we just plug these things into our formula for f, we get f of b is 100 plus 20b minus 5b squared. And then we're subtracting f of 1, which is 115. All of this is over b minus 1. And simplifying a little bit, on the top, we're going to have minus 5b squared plus 20b minus 15 divided by b minus 1. Now remember that we want the limit as b approaches 1, but if we leave it in this form, then our numerator is going to be going to 0 as b approaches 1, and our denominator is also going to be going to 0. So that's not going to be good enough. We need to do some more work, and we're going to have to factor here. So we're going to get on top minus 5 times b squared minus 4b plus 3. And on the bottom, we still have our b minus 1. And this polynomial we can factor further. We'll get minus 5 times b minus 1 times b minus 3 all over b minus 1. We get some cancellation here, and we're finally left with minus 5 times b minus 3. So moving back up here, we say that this limit is the limit as b approaches 1 of minus 5 times b minus 3. Now this is continuous, so we can just plug in b equals 1. And so we're going to get minus 5 times minus 2, which is 10. All right, and 10 what? Well, remember that the output of f is meters. The input that's going into f is measured in seconds, so the derivative of f should be measured in meters per second. So that's our instantaneous velocity at time t equals 1. It's 10 meters per second. Let's take a moment and think about why this answer is different from the 15 meters per second that we got for the average velocity. The average velocity is referring to a time interval from t equals 0 to t equals 1. And what happens during that time is, well, at t equals 0, that's when we throw the pumpkin. So it's starting with an initial upward velocity, and I'll use this arrow to denote that. But then during the 1 second, gravity starts to take over. So the pumpkin's going to go slower and slower during the 1 second until at the end of that period, which is at t equals 1 exactly, the pumpkin's velocity is slower than any velocity that came before. So that's why the instantaneous velocity at t equals 1 is slower than the average velocity over the period from t equals 0 to t equals 1. Let's do one other calculation really quickly. Let's find the instantaneous velocity at t equals 3. So I'll erase this, and we want f prime of 3. So by definition, that's just the limit as b approaches 3 of f of b minus f of 3 divided by b minus 3. So to calculate the limit of this thing, let's try to simplify it first. We want f of b minus f of 3 divided by b minus 3, and that's equal to, well, f of b is just 100 plus 20b minus 5b squared. And then we're subtracting f of 3, which is 115. And then all of this is over b minus 3. And notice that this numerator is exactly the same numerator as we had before in our f prime of 1 calculation. So it's going to factor in exactly the same way. So we're just going to get minus 5 times b minus 1 times b minus 3. And all of this is divided by b minus 3, and we get cancellation. So we end up with minus 5 times b minus 1. So putting that above, we want the limit as b approaches 3 of minus 5 times b minus 1. This is continuous now, so we can just plug in b equals 3, and we're going to get minus 5 times 2, which is minus 10. And that's measured in meters per second. So what's the deal with this minus sign? Why don't you take a moment and think about it?